Hi all. Till now what we have discussed with respect to the hydraulic, pneumatic, actuators and motors. Now what we are discussing is with respect to the electrical motors. Electrical motor is a machine which converts electrical energy into a mechanical energy. AC motor and DC motor. AC motors that runs on the alternating current electricity. DC motors that runs on direct current electricity. Now, the classification of the motors. Electric motors are classified into alternating current motors, direct current motors. Alternating current motors are classified into synchronous, induction and universal. Even in the induction also, single phase and as well as three phase motor. Direct current motors are discussed further in the rest of the slides. Now, AC motors. AC motor is an electric motor driven by an alternating current. Commonly consists of the two basic parts: an outside stationary stator having a coil supplied with alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft that is given a torque by the rotating field. The two main types of AC motors depending on the type of the rotor. They are synchronous motor and as well as asynchronous motors. DC motors. DC motor is an electric motor that runs on direct current electricity. The two types of DC motors are the brush and brushless DC motor. Brushed DC electric motors generate torque directly from the DC power supply to the motor by using an internal commutation stationary magnet and a rotating electrical magnet. Brushless DC motors using a rotating permanent magnet or soft magnetic core is the rotor and a stationary electric magnet on the motor housing. Now, types of the DC motor. The classification of the DC motor depends on the way of the connecting the armature and the field winding of the DC motor. The DC shunt motor are of two types: to DC series motor and compound motor. Shunt motors are of two types: cumulative compound motor, differential compound motor. Even in the shunt motor, the cumulative compound motor, differential compound motor. In general, the DC motors are classified into three types. The first one is a DC shunt motor, second one is a series motor, and third one is a compound motor. Now, electrical motors are further differentiated by the AC motors and as well as the DC motors. Now we will see in this slide a comparison or a differentiation between the AC and as well as the DC motors. As we know that the supply in the AC motor is AC, but in the case of the DC motor it is of DC. Now in the case of the AC motor, the starting needs the starting mechanism for a single phase, not for the three phase. But in the case of the DC motor, self starting is easier. Next, the supplying system. Supplying system in the case of the DC motors can be a single phase only, and here in this case can be a single phase and three phase also. The starter and rotor action. In the case of the AC motor, starter remains standstill and supplies the rotating field while the rotor rotates. Armature rotates and the field winding remains standstill in the case of the DC motor. Brushes and computers. In the case of the AC motor, do not have the brushes and commuters, but in the case of the DC motor have the brushes and commuters, which limits the speed and reduce the life expectancy. The speed control in the case of the AC motor is by means of the frequency, but in the case of the DC motor the speed control is by means of the winding current. In the case of the AC motor, the characteristic The AC motor is in a induction type, but not in the case of the DC motor. The speed and the torque. In the case of a AC motor, uses a high speed and a variable torque, but in the case of a DC motor, a user uses a variable speed and a high torque. The load changing capacity in the case of AC motor is slow response to the change in load, but in the case of the DC motor, it is a quick response. With respect to the efficiency, AC motors are less efficient and DC motors are more efficient. Armature locations. Armature remains stationary and the magnetic field rotates, but in the case of the DC motors, magnetic field remains standstill while the armature rotates. The uses of the AC motor is primarily used in large industries and factories, but in the case of the DC motor are having a major application in domestic applications. With respect to the maintenance, as we know that in the case of the AC motor that requires a less maintenance because of the absence of the brushes and commuters, but in the case of the DC motors that demand extensive maintenance frequently. Now, application of the DC machines. The DC machines can operate on either a motor or a generator. At present, its uses as a generator is limited because of its widespread use of AC power. Large DC motors are used in machine tools, printings, presses, fans, pumps, cranes, paper mills, tractions, textile mills, and so forth. The small DC motors are having a fractional horsepower ratings are used primarily as a controlling device such as tacho generators for the speed sensing and servo motors for position and the tracking and the use of the robots. The advantages of the DC machines: high starting torque, rapid acceleration and deceleration. The speed can be easily controlled over a wide range through gobs built in a wide range of sizes. The main disadvantages of the DC machines is it needs a regular maintenance and cannot be used in explosive area, and the cost of the DC machines is little higher when compared to the AC machines.